Hey everyone, Grant K for the Flame Learning channel. In this video, I'll show you a new workflow using PBS Ambient Occlusion texture maps to texture indirect lighting onto 3D models in action. This allows you to get the same render quality for indirect lighting and shading on 3D geometry that you would normally get by outputting 2D render passes using your favorite 3D renderer. Special thanks to turbosquid.com for the model being used in this video. You can purchase this model and many others by signing up to their website. Now I have an action setup that contains an imported FBX model. I've already added an IBL for lighting, as well as a shader node to enable physical-based rendering in action. As part of the original FBX export from Maya, the textures are included, but typically no lighting is baked into the textures. This means you could use Flame to relight the model any way you like. You can use the ambient lighting or different light objects to add direct lighting into the 3D composite. And if you are also adding indirect lighting, one component you can consider using is ambient occlusion. This has been implemented in a few ways in Flame, and hopefully you'll get great results with a high level of interactivity. So the first option is to click on the Output menu and enable Ambient Occlusion in the Comp Render Pass settings. This is done through the Action Render engine, and you can adjust your settings to taste. If you orbit the scene, you should see detailed shading in the model and on the ground plane geometry. The second variation of Ambient Occlusion is done as a post-processing process with camera effects. I'll disable the settings in the Output menu and switch back to the Action node bin. The camera effects is applied to the camera of the composite, so select the camera node in the Action schematic. In the Action node bin, switch to the Matchbox tab. Now locate the Stingray Ambient Occlusion shader. Drag it out and it will attach to the camera. For more information about Matchbox and camera effects, please watch the other videos available on the Flame Learning channel. Now this camera effects is using the Stingray gaming technology to generate indirect lighting based on Action's 3D environment. The result is pretty good, and there are lots of settings in the camera effects menu to tweak the shader. As you can see, there is nothing wrong with either indirect lighting method. However, if you want to push the quality of the ambient occlusion even higher, you can use your 3D application's rendering engine to create and bake the indirect lighting as an ambient occlusion texture map. We'll cover the other advantages of this when we come back to Flame. So I'm using Maya 2017 as my 3D application and the Arnold renderer as my renderer of choice. This is the same 3D geometry that was exported out as an FBX. Now creating flat render passes will bake in lighting and ambient occlusion to the rendered images. That's pretty standard. However, the physical 3D geometry is already in Flame, and we want to apply a separate ambient occlusion pass to add indirect lighting to the actual 3D geometry in action. So here's what you do. First, you need to retexture all the 3D geometry with an ambient occlusion shader. But before you do this, iterate or save a copy of your scene to ensure you can go back if needed. Now, if there is any geometry that does not need ambient occlusion, like glass for instance, make sure you hide the geometry to exclude it. Select all the geometry in the scene. I've also intentionally left a ground plane to capture the indirect lighting as the feet make contact with the floor. With all the geometry selected, right-click on the pop-up menu. Choose to assign a new material. In the list, choose the Arnold shaders to bring down the options. Here you will find a shader called AI Ambient Occlusion. Select the shader and replace all the materials. To see what it looks like, switch to the Arnold tab and call up the Arnold Interactive Viewer. So this is our ambient occlusion render, but it's a rendered view from the camera. To bake the ambient occlusion to a texture, go to the Arnold pull-down menu. Select Utilities and choose Render Selection to Texture. In the pop-up window, choose the output folder and set a render destination. Now you can increase the resolution for a larger texture if required, but very importantly, increase the camera samples for a higher quality render. Now bake the textures. Maya will create one texture per geometry for separate shading. Once this is done, save your project. Now the renders are in the designated folder, and you should make them accessible to Flame. Let's switch back to Flame and see how to apply them to our 3D model. At the end of the video, I'd like to look at the differences between using Camera Effects Ambient Occlusion and the baked AO texture in action. So select the action node and duplicate it with Ctrl-D. Now let's import the AO render passes. In the Batch Schematic node bin, drag out the import node to launch the media browser. I'll navigate to the AO passes and select all the textures. Import the media and they will appear as source clips in the batch schematic. Select the action node and create 5 new media inputs with Ctrl-N. Next, connect each render pass to the front input of a media input node with Shift-Alt and Kiss. Now bring up the action controls and switch to the 2-up view. In the action schematic, delete the 5 image objects that have been created as surface objects. We need these as textures and not 3D objects. Also delete the Stingray Ambient Occlusion camera effects, as we'll compare this composite with the original action node. So let's start adding PBS maps to the PBR textures. Double-click the group node to enter it. Now switch to the node bin menu. I'll choose the first AO texture and switch to the Maps tab. Looking at the nodes, the naming conventions between the geometries and their textures should match. So you would select the Material node matching the first texture and add the PBS map from the node bin. Nothing happens by default because the PBS map is undefined. Go to the Material properties and change the material type to AO. If you toggle the AO texture with the H keyboard shortcut, you can see the difference with and without the ambient occlusion. Now we'll jump forward in time to when most of the AO maps have been applied to the 3D geometry. So that's all the ambient occlusion maps applied to the robot. The last AO map to apply is to the ground plane. Select the group schematic and press tilde to return to the main action schematic. Select the ground material node. Go back to the action node bin and locate the ground AO texture in the media list. Add the PBS map texture to the geometry and set the material type to ambient occlusion. If you orbit the camera in the 3D scene, you can see the amazing indirect lighting you can achieve in action using baked ambient occlusions from your 3D application. Now let's compare this to the Stingray ambient occlusion generated in Flame. Go back to the batch schematic. Call up the contextual menu on the original action node and choose Set as Next Available Context. Select the action node with the AO passes and go back to the 3D scene. Now select the action schematic and change the viewing mode from action schematic to context 1. So the Stingray camera effects result is on the left. This is being generated live in Flame. And the AO baked texture result on the right was generated using Maya and the Arnold renderer. The most obvious difference between the two results is the shading between the floor and the robot's feet. Before you choose your favorite, it is important to point out that these are 2 different approaches to applying ambient occlusion in Flame. This all depends on what you're out to achieve, and each one has its own advantages. Using the camera effects stingray approach, you can manipulate 3D objects in the Action 3D space, and the 3D environment will generate the ambient occlusion based on the position of different objects within the same 3D composite. So if you're still manipulating 3D objects in Action quite a bit, then you might take this approach. This contrasts with the baked AO texture approach, which is much more precise, because the AO was baked in the 3D application as part of this workflow. Using this approach, you can't manipulate the objects in the Action 3D space too much, because the ambient occlusion is already committed in Flame. Now you can still orbit the camera and move around the 3D environment, but you will see the issues if you try to move the 3D geometry in the scene. Ultimately, you choose the approach which is best suited for the job. And in the workflow of using the baked ambient occlusion texture for indirect lighting, it will certainly help bring your 3D composites up to the high quality you would normally expect with 2D render passes coming from a powerful 3D render engine. Be sure to check out the other features, workflows, and updates to the Flame 2017 Extension 1 products. Comments, feedback, and suggestions are always welcome and appreciated. Thank you for watching, and please subscribe to the Flame Learning channel for future videos.